Alright, in this section we're going to look at another method called the AC method to factor. We're also going to finish off the section by talking about factoring completely and solving polynomial equations. Okay, so the AC method, what we're going to do is we want to multiply the leading coefficient A and the constant C. So the first and the last numbers. We want to find a pair of factors for that result that combine to B. From there, we're going to rewrite the middle term, as a sum or difference using the factors found in the previous step, and then use factor by grouping to factor the problem. Alright, so let's go ahead and see how this works. For example A, we want to start by multiplying our 3 and our 8 together. 3 and 8 multiply to 24. And now I want to list all the possible factors for 24. So we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now we do want to be careful because 2 of these options combine to 10, so we need to make sure we're using the right operation. Because we are multiplying to a -8, remember this is different signs. And remember, when we talk different signs, we want to subtract to 10. So which pair subtracts to 10? We want to use the 2 and the 12. So I'm going to go ahead and put these numbers in there. We're going to rewrite the 10x using 2 and 12. In order to combine to a 10, I want this to be a -2x plus a 12x. From there, we're going to use our factor by grouping. So remember that with factor by grouping, we're going to take the first 2. We're going to factor out the GCF. In this case, it's an x. If we factor out an x, we are left with 3x minus 2. For the second set, what can we factor out? We can factor out a 4, and we're left with 3x minus 2. And then we factor out the common binomial. The common binomial is 3x minus 2. And the first thing, if we get rid of 3x minus 2, we are just left with an x. And the second thing, if we factor out 3x minus 2, we are left with plus 4. And we're done with our factoring. All right, let's try a couple more just to make sure we got it. For example, B. Again, I'm going to start by multiplying my A and my C. 6 times 12 is 72. All right, let's find all the things that multiply to 72. We have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. All right, so let's see what we want. If we're multiplying to a positive 12, remember this means same signs. And remember that if we are talking same signs, we are looking for something that adds to 17. That's going to be my 8 and 9. So how do we get 8 and 9 from negative 17? I want it to be negative 8 and negative 9 W's. All right, let's go ahead and factor. In the first two terms, we can factor out a 2 and a W. If we divide each term by 2W, we get 3W minus 4. In the second set, I want to factor out a negative 3. Negative 9W divided by negative 3 is 3W. And 12 divided by negative 3 is negative 4. Make sure that you divide by that negative as well. All right, from there, we can factor out the common binomial. We can factor out a 3W minus 4. In the first thing, if we get rid of 3W minus 4, we are left with 2W. And in the second thing, if we get rid of the 3W minus 4, we are left with minus 3. And this is factored. All right, last one. We start by multiplying A and C. We get 6 times 20 is equal to 120. All right, things that multiply to 120. We get 1 and 120, 2 and 60, 3 and 40, 4 and 30, 6, ooh, sorry, missed one. I missed by 5. 5 and 24, 6 and 20, 8 and 12, no, 15. And 10 and 12. Okay, so those are all my factors. So now let's see here. Remember that in order to multiply to negative 20, we want different signs. We're looking for a pair that subtracts to 7, so we're going to go with 8 and 15. All right, so let's go ahead and put these in our problem. So we get 6x squared. In order to get from 8 and 15 to 7, I want a minus 8x and a plus 15x. Now it doesn't matter what order you put those two terms in. Me personally, if you struggle with that middle, with factoring out that negative, I always try to put my plus sign here so that we don't have to worry about it. But you should get the same thing either way. All right, so now let's go ahead and factor using factor by grouping. So in the first set, I can factor out a 2x. I am left with 3x minus 4. In the second set, I can factor out a 5. And I get 3x minus 4. We factor out the common binomial. In the first set, in the first thing, if we get rid of 3x minus 4, I am left with 2x. In the second thing, if I factor out 3x minus 4, I am left with plus 5. And that's basically the AC method. Now, if you are going to use this on your homework, on your quizzes and tests especially, the main thing is you need to show this right here. You need to show where you are getting these two numbers. Otherwise, I'm not sure exactly how you're doing the problem, and I'm going to go on the assumption that you're using programs that show it to you. So make sure that you do show where are you getting these numbers that you're using. All right, so that's the basics of the AC method. Let's go ahead and extend this into our problems that involve factoring completely. All right, so for example A, the first thing we want to do is go ahead and factor out the greatest common factor. We don't have any number in our greatest common factor. 6, 19, and 10 have no common factors. But every single one of these terms has x's in it. How many do they all have in common? They have 4. So I'm going to factor out x to the 4th. And if we go ahead and do this, we get 6. If I have 6 x's and I factor out 4 of them, I'm going to be left with 2. Minus 19. If I have 5 x's and I factor out 4, I'm left with 1. My last term, we've already factored out all of them. All right, from here, let's go ahead and do our AC method again. We're only going to work with the polynomial inside, so we're going to do 6 times 10 gives me 60. And now if we go ahead and factor 60, we get 1 in 60, 2 in 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. What are we looking for? We have same signs, and remember, same signs means we want to add to 19. So we're going to go with the 4 and the 15. All right, so I'm going to bring down my x to the 4th. I'm going to rewrite my middle term to get from 4 and 15 to negative 19. That means both of them have negative signs, so we get negative 4x minus 15x plus 10. All right, in the first set, what can we factor out? We can factor out a 2x. If we divide each term by 2x, we are left with 3x minus 2. In the second set, I can factor out a negative 5. And if we divide each term by negative 5, we get 3x minus 2. Make sure you don't forget your x to the 4th. All right, then we go ahead and factor out the common factor, the common binomial. So if we factor out the common binomial of 3x minus 2, in the first thing I'm left with 2x, and in the second thing I am left with minus 5. Don't forget to bring down your GCF. Our final answer is x to the 4th times 3x minus 2 times 2x minus 5. Let's try one more. Example B. We start by factoring out the greatest common factor. All of these numbers are divisible by 2, so I can factor out a 2. And they all have at least 2 x's in common. All right, so if we go ahead and factor that out, what are we left with? The first one, if we divide by 2x squared, I am left with 3x squared. Second one, if I divide by 2x squared, I am left with 58x. And the last one, if I divide by 2x squared, I am left with 40. All right, using the AC method, we get 3 times 40 equals 120. And so now what multiplies to 120? We get 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 8 and 15, and 10 and 12. All right, so let's see here. In order to multiply to the negative 40, we have different signs. And remember that that means subtract. So the one that we want to go with is the 2 and 60. So if we go ahead and rewrite this, I get 3x squared. To get from 2 and 60 to negative 58, that means I need a negative 60x and a positive 2x. All right, first set, we can factor out a 3x. I am left with x minus 20. Second set, I can factor out a 2, and I am left with x minus 20. Bring down our 2x squared. All right, from there we can go ahead and factor out the common binomial. The first thing, if I get rid of the x minus 20, I am left with 3x. The second thing, if I factor out the x minus 20, I am left with plus 2. Bring down our common factor, or our GCF, and we are done with our factoring. All right, so make sure that when you do these problems that you do factor out greatest common factor to start off with. Otherwise, instead of, granted I understand 120 isn't exactly the nicest number, but it's a lot better than multiplying 6 times 80, which is 480. That's a lot more factors than what we want to deal with. All right. Last thing we want to do is take this and apply it to some solving problems. Again, I don't care which method you use, I just want to show you a couple more using the AC method. So this one, if we multiply 3 times 4, we get 12. Things that multiply to 12, we get 1 and 12, 2 and 6, 3 and 4. In order to multiply to a positive 4, we do have same signs. And remember that with same signs, that means we want to add. So we're going to go with 2 and 6. All right, if we go ahead and put these in our problem, we get 3x squared. In order to get from 2 and 6 to negative 8, that means that we need a negative 2 and a negative 6. Both of them with x's. From there, we can go ahead and factor. In the first set, we can factor out an x. I am left with 3x minus 2. In the second set, I can factor out a negative 2, and I am left with 3x minus 2. 4 divided by negative 2 is negative 2. And now if we factor out the common binomial, we are left with 3x minus 2. The first thing, if I get rid of 3x minus 2, I'm just left with x. And second thing, if I get rid of 3x minus 2, I am left with minus 2. All right, now we are solving, so remember that we want to set each factor equal to 0 and solve. So we get 3x minus 2 equals 0, or x minus 2 equals 0. For the first one, I can add 2 to both sides. And I can divide by 3. We get x equals 2/3. All right, the second thing, I can add 2 to both sides. And I get x equals 2. If you want, we can put this in squiggly brackets. And we have our answer. Okay, let's try a couple more. Let's try example B. First thing I notice is everything here has an n, so I want to factor it out. If we factor out one n from each term, the first one becomes 8n squared. Second one, we're going to be left with 10n. And the last term, we're going to be left with a 3. All right, so if we multiply our first and our last, we get 8 times 3 is 24. Things that multiply to 24, we get 1 and 24, 2 and 12, 3 and 8, 4 and 6. In order to multiply to a positive 3, we have same signs. And remember, when we combine things with same signs, we are looking for things that add. So which pair adds to 10? We want to go with the 4 and 6. All right, let's put it back in our problem. We get 8n squared. In order to get to positive 10, I want 4n plus 6n. And we bring down our plus 3 and our equals 0. All right, first set, first pair. We can factor out a 4n. I am left with 2n plus 1. The last two terms, I can factor out a 3, and I am left with 2n plus 1. We still got that n hanging out over on the side, so we need to bring it down. All right, so now if we factor out the common binomial, we get 2n plus 1. If we factor out 2n plus 1 from the first thing, I am left with 4n. If I factor out 2n plus 1 from the second thing, I am left with 3. Bring down your equals 0, and bring down your greatest common factor. All right, let's set each factor equal to 0. We get n equals 0. Make sure you remember this. We get 2n plus 1 equals 0. And our last one is 4n plus 3 equals 0. All right, if we solve, first one we want to subtract 1. Divide by 2. And we get n equals negative 1/2. All right, last factor, if we subtract 3 from both sides, we get 4n equals -3. And then we can divide by 4. We get n equals -3/4. So my solutions are 0, -1/2, or -3/4. All right, last problem. This one, the first thing that we want to do is we need to get everything set equal to 0. And the first thing I want to do is I actually want to go ahead and distribute my x to clear my parentheses. So we get 5x plus 12x squared equals 28. I'm going to subtract 28 from both sides. And I also want to write this in descending order. So I want my 12x squared first, then my 5x, and then my -28. Now, one of the drawbacks for the AC method, this problem, I really don't want to do AC method on this problem. 12 times 28, I'm not going to be able to multiply that without a calculator. And to me, that just seems too hard. So if you guys are okay with it, I'm going to use Sarah's rules of factoring on this one. So the first thing I'm going to do is, we can't factor out a greatest common factor. So I want things that multiply to 12. We get 1 and 12, 2 and 6, 3 and 4. All right, 28. What multiplies to 28? We get 1 and 28, 2 and 14, 4 and 7. Okay, off the top of my head, let's go ahead and see what we can cancel out. 5 is an odd number, which means that I want to get rid of any pairs of even numbers. I also consider 5 to be fairly small, which means I don't want to work with extremes. So I'm going to get rid of my 1 and 12 and my 1 and 28. And that leaves me just with basically one option. 12x squared is going to be 3x and 4x. My 4, remember, cannot go in the same set as 4x because they have common factors. So it needs to go over here. And that means my 7 goes here. All right, we do have different signs. And I want my larger quantity to be positive. So what is larger? 21 or 16? 21 is larger, so I'm going to make this a positive 7 and a -4. If we do a quick mental check, let's just check our outsides and our insides. Outsides, we get 21 minus insides, which is 16. 21 minus 16 is, in fact, 5, so we are good. So now let's go ahead and set each factor equal to 0. And solve. We add 4 to both sides, divide by 3, and we get x equals 4/3. On our second factor, we can subtract 7 from both sides. We can divide by 4, and we get -7/4. So my solutions in My squiggly brackets is going to be 4/3 and -7/4. And we're done. Okay, so as you can see, AC method does require a little bit more lines of work just because you are going to be doing factor by grouping. And one of the other drawbacks to this method is, for instance, on example C, 12 times 28, trying to multiply that and then trying to find all the factors of that is, it can be a bit of a challenge. So AC method works really well when you are dealing with numbers like 12 and 24, but when you get into the harder factorings, then it may not be the best method to use. All right, that takes care of this section. We have one more section on factoring, and we're going to look at our special products. All right, so go ahead, work on the homework. If you have any questions, if you need help with any of these factorings, please contact me, and I will help walk you through it. Okay? All right, good luck.